Good morning. I'm sorry that it's taken me a couple of days to get these last two examples from last week's um, normal model discussion in chapter 7, but I'm getting them to you now. So here is my example from section 7.3, which is just basically applying basically everything we've learned about z-scores and the empirical rule into a question about a normal model. So just to review, this is our normal model with the empirical rule. We know that when we set up any normal distribution, we need to know two things. We need to know the mean, which is the middle, and then the standard deviation, which is how far you move, right? So again, this mean value is where we are to start in the center. And then the standard deviation is how far we're moving every time we take a step to the side, right? So that'd be one standard deviation away. That'd be this middle section here, that's 68% of the data. And if I move out two steps each way, that's two standard deviations. That would be about 95% of the data. And then if we move out all the way to 3, that's almost the entire curve. And that's about 99.7%. So we call that the empirical rule. Then everything else in between, we use our calculator for that. And if you remember from the previous video, we use the normal cumulative density function on our calculators to give us areas both to the left of a value, they can be to the right of a value. These are always probability. Or we can actually find out what's the value in between, like for the empirical rule, but it could be for values that are not necessarily at 1, 2, or 3 standard deviations away. So let's look at an example here. You have a normal distribution with a mean of 10 and a standard deviation of 2. So we're not really told what this is for, so this is just some practice with modeling. So we know that, and we want to find the probability that an x value selected at random from this distribution is between 11 and 14. So what is this thing going to look like? I always say first draw a picture. So we're going to write out our model. Our model is going to be centered at 10, and we're going to reach out 2 units in each direction every time we move. So I'm going to draw my curve. I have to practice doing those. Don't worry, the more you practice, the better you get. So again, my center is going to be 10. And I gave you a really easy standard deviation. So if we move out 1 unit to the right and 1 unit to the left, that's going to take me out to 12 and back to 8, right? And if you recall, that's going to be 68% of the data. If I move out 2 more steps away from the middle, I'll be out at 14 and then back at 6. And again, that's going to be 95% of the curve. That's our second in the empirical rule. And then if I go all the way out 3 steps, I'm almost to the end of the curve here. I'll be at 16 and 4. And that gives me 99.7%. Almost everything falls within that range. So the question's asking, what is the probability that a value selected at random is going to fall between 11 and 14? So let me use a different highlighter here. For 11, I'm going to go right here. I'm going to draw a line right there. So that's my 11. And then 14 is right here. And I'm just going to look at this area inside that chunk. So first thing we notice is that 11 is not right at a number that we like. So we're not going to be able to use our empirical rule. But we can see that it's going to be a chunk, probably, bigger than maybe 30%. And I know that from experience because this little area between 8 and 10 is 34%. And this little area from 10 to 12 is also 34%. So this chunk, that chunk I just shaded in probably is going to be around that. But we're gonna look. I'm gonna put some yellow in here so we can. So that's our area. If I didn't have the whole curve, I could just do a quick little, and I do 11 to 14. So when I ask you to draw a picture, it should look like that. So I'm just going to use my calculator, like we learned in the previous videos, and we're going to use the normal CDF. So it's a cumulative density function between 11 and 14. So we're going to say normal. And I might do this handout in 2 videos so it doesn't get too long. Normal CDF, my left limit is 11, my right limit is 14. Remember, this is your lower and your upper. And then the mean is the next thing we put in there, that's 10. And then my standard deviation is the last thing, that's 2. So these last 2 values are always the same for this particular function. So let's go and look at our calculator. Our calculator's here. And I've told you how to get one of these calculators. You can also get the ones that we use in class for your computer. If you don't see the link, you can just send me a message and I'll give it to you. It's free for 6 months. This one that I'm using right here is free for your iPad or I think it's good on the phone. So normal CDF, my lower limit's 11, my upper limit is 14, my mean is 10, and my standard deviation is 2. So I predicted around 30%, so let's see. 28, not too bad, 0.2857. So it's good to be able to predict things. You have a good chance of getting it correct if you're looking at what the answer could possibly be. I know it had to be something around 30%, but if I had gotten an answer like 2%, I knew I did something wrong there. Right? So it's always good to know what you're looking for, so you have a better chance of knowing if you got the answer right. So that's our probability, is about a 28.5% chance that will fall between those 2 values. So let's move on to the next question. So if you have questions on this, office hours is a great time to ask me questions. And so far I haven't had a lot of people showing up to office hours, so I invite you to do that. Office hours are at 10 o'clock on Mondays and Thursdays. A company produces CD players, that's one of those round things that they use to put music on, has a mean life of 2.3 years and a standard deviation of 0.4 years. And what's the probability that the CD player will break during the warranty period of 2 years? So that's really important. They want to know what's the probability that they're going to have to pay somebody out for the warranty. You know, like when you get an iPhone and it says it's insured for a year by Apple, and then what's the chance that it's actually going to break within that year and Apple's going to have to pay? So for this is a CD player. That's my phone, so I've got to turn it off. So this is normally distributed. They usually last 2.3 years, and the standard deviation is 0.4. So if I wanted to look at a little picture of that, because I like to, 2.3 is here, and if I subtract 0.4 from that, I'm going to get 1.9. And I really only care about that side because they want to know what's the probability that it's not going to last up to 2 years. So if I look again, let me get my highlighter here. Just go a little bit to the right of there. 2 is going to be right past 1.9. So I want to know, what are the chances that it's not going to last past 2 years? And it's almost 1 standard deviation away, so I'm going to predict almost a 20% chance. So I'm going to know what is the probability that the CD player will last less than 2 years. So that means my lower limit. Now again, we have to talk about lower limits. In statistics, usually the lower limit is infinity, but in real life, how long what's the shortest amount of time that your CD player will last till it breaks? Well, we would say 0, right? You get it, you turn it on, it's broken. And then it can go all the way up to 2 years. So that's good enough for this example. And then our mean is 2.3 and our standard deviation is 0.4. So again, this is the lower, the upper, the mean, and the standard deviation. We're going to go back to our calculator. We're going to use second, vars, normal CDF. Our lower is 0. Our upper is 2 years. That's when they're going to have to pay. But most of their CD players last at least almost 2.5 years. But there is variation. So sometimes they last longer and sometimes they don't last as long. So I predicted 20%. It's actually a little bit over that. So 0.2266. So we should talk about that. If I were a producer, that means that almost a quarter of my CD players are going to break within the first 2 years. So that's to be of concern. That means 1 out of 4 people are going to be asking me for a new CD player within the first 2 years, and I'm going to have to pay for it. So something must be up with my production if that many CD players are breaking within the first 2 years. So that's where this stuff becomes very important to, in this case, a manufacturer. And they'd have to do something about their process in order to get this. Now, what could they actually change? They could change the mean, and they could also change the standard deviation. So by making their production better quality control, they might be able to make this number here them last longer, and then also the variation, meaning the consistency, actually smaller, so that the chances of it lasting past 2 years will be breaking within the first 2 years would actually go down. All right, and number 3, and then I'm going to stop this video and do a second one for the remaining questions on this handout. Nintendo has a console that has a mean life of 30 months. So we know the mean is 30 months. That's almost 3 years. Nintendo consoles have been breaking quite a bit. Ours broke. And the standard deviation is 4 months. The controllers are not so good, even though it's a great game. The console life is normally distributed. And how long can the company guarantee their consoles so that they only have to refund 7% of their consoles? So we're going to look at this a little bit differently. We know that the mean is 30 and the standard deviation is 4. And they want that percent, like we did up here, to only be 7. So if you think about it, they just want this much. They want this little chunk here to be 7%. And we want to know what goes there. When we know 30 goes in the middle and the standard deviation is 4. So if I start subtracting 4, 1, 2 times, this is probably going to be 26 months, and this is going to be 22 months. And if I go one more step, I'm going to be down at 18 months. So it looks like that 7% is going to be somewhere between 18 and 22. And how do we get that? Well, if you remember, when we go backwards, we do the inverse. So we're going to use the inverse normal. And we know it's 7%. So you need to know first the percent, and then you need to know the mean and the standard deviation. So in this case, it's 30 and 4. And on the calculator, it's right where we found the other thing, second vars, but we do number 3. And again, that we only want 7% chance that they have to replace the console. And the average life is 30 months, and the standard deviation is 4 months. So the amount of months they'd have to guarantee it for would be 24 months. So 24 months is actually a little bit more than I had predicted. It's actually more than 2 standard deviations away, but that makes sense because that would fall about right here. 2 standard deviations away is about 5%. So I just made a little mistake here in my prediction. It should go about up to here. And I'm going to give you a new picture just to not confuse you. So we said it came out to be 0.24, which should be 24 months. And just so I'm giving you a good picture here, if this is 30 in the middle, then if I move over 1 standard deviation, that's going to be 26. And if I move over 2 standard deviations, that's going to be at 24. And the distance here, if we look at that in our up to 2 standard deviations, is actually 2.5%. So that area up to there is this is 22, sorry, is 2.5%. So 24 is what we solve for. That's going to be, we said that came out to be about 7%, because the curve gets more and more area as it goes up. All right, just want to make that picture a little bit more accurate. Okay, we'll go on in the next video and finish this handout.